So write the electron configuration for the Tc element. Also write electron configuration for Tc plus and Tc2 plus. So how can we do this question correct? But firstly, we have to know the correct electron configuration for the Tc element. And Tc has 43 electrons. So which means that we can have two different electron configurations in our case. So firstly, I will write the electron configuration. First possible electron configuration is 4d, 4 and 4s2. The other electron configuration is 4d5 and 4s1. So which electron configuration is correct? Before making this, we have to, know the Aufbau Principle. And according to the Aufbau Principle, it describes how electrons fill orbitals in an atom, starting with the lowest energy levels first. So we have to know that. But before going on the question, can we use the Z effective nuclear charge for the correct electron configuration? And simply the answer is no. So D group elements can become complicated, and you might think that can we use the Z effective nuclear charge even if we have the Slater's rule? For calculate the S, we are using the Slater's rule or Slater rules. Actually, there are more than one rules. And can we use the ZF? The answer is no, since ZF calculation does not account for subtle energy differences between the s and p orbitals, exchange energy, and electron-electron repulsion. And there are some exceptions. Firstly, half-filled D5 configuration can be more stable due to the exchange energy. So if you look at the question, you might think that this is more stable configurations, but there are some exceptions. But first, I want to write the rules. First rule, half-filled D5 configuration can be more stable due to exchange energy. But is it valid for the Tc elements? We don't know right now. And is there an exception for this rule? The answer is unfortunately yes. Is there an exception? And for exception, niobium is a good example, I think. If you look at the niobium element and its configuration is chromium 5s2 and 4d4. If you consider this rule, according to this rule, the correct configuration should be 5s1 and 4d5. Unfortunately, this is not correct. This is a big issue for us. If you follow it more, you will understand. So there is an exception. Niobium is an exception for this rule. And the other rule, before continue this question, the other rule is D10. And D10 configuration is especially stable. Palladium, chromium 5s2 and 4d8 electron configuration, but it is not. Silver might be a good example, and you might, for instance, expect to see chromium 5s2 and 4d9, but in this case there's no exception, and the actual and the correct configuration will be 5s1 and 4d10. The reason is that the D10 configuration is more stable than this configuration. So the D10 configuration is very stable. I want to show other elements. So for instance, we have a Tc here, 43, 43 is our TC element, and this is the correct electron configuration for the TC elements. But again, there are some exceptions, and the 5 electron configuration might be stable in some cases, not all cases. And how can we see the exceptions? So there is no rule. You have to know the exceptions, and to know the exceptions, unfortunately, you have to memorize. Niobium was one of them, and the last electron configuration finishes as 5s1, and we can, I think, look at the other D4 and D3 configurations. It is possible, but I think the easier way to memorize the electron configuration for the last orbital, and I prefer to memorize the S1s. So for instance, molybdenum also finishes as S1 here, and the other S1 is this one. So maybe you might expect to see 5s2 and 4d6, but this is not the case here for the ruthenium case. So this is also important, and therefore memorizing the elements that finish with S1 can work for us. Since if I know the last electron number, then I can know the electron number in the D elements. And palladium, I think, very interesting. I want to make it a little bit yellow, since there is no electron for the S element. Again, S electron, sorry. And silver is interesting. It finishes as S1, but I think we have to color it with this color. And I can look at the other one, for instance, chromium. There is no exception for the chromium, so the 5 electron configuration is stable here. And copper is interesting, and it finishes as 1. So it is not interesting, I think, but it finishes with the S1 configuration, so we have to know that. And gold also finishes with S1, so it is important. Platinum is important. We have to know that before an inorganic chemistry exam. And the good thing is that we don't have to worry about the last row. So in the last row, our job is very easy. We don't have to memorize any configuration. The first thing we have to look at that in the last row, all of them finishes with S2. So there is no S1, which is good. And they also contain the 5F14. So our job is very easy for the last row. We don't have to worry about the last row. So we don't have to memory anything here. But for the other elements, we have to worry, and these are the all correct electron configuration. By the way, I wrote the other elements configuration here, but I didn't wrote, for instance, here and here to make it less crowded. And we can go back to the question. So this is our question. So you saw that the electron configuration for the TC element, and which is this one. This one is correct electron configuration. So we are lucky, I think. If this is the question, there is no exception. Of course, you might not be lucky always. And this is the correct electron configuration. So if we look at the Tc plus electron configuration, it should have 42 electrons. And we have to consider the Aufbau principle. So the most energized electron is s electron. So we have to remove the s electron. Therefore, the correct electron configuration for this element should be 4d5 and 4s0. And for the Tc2 plus, it has 41 electrons, and the correct configuration should be 4d4. So this is the answer our question. But before taking a chemistry exam, you should know at least the number of s electrons for the chromium, copper for the first row, for here, and you have to know the Nb, molybdenum, ruthenium, Rh, palladium, silver, this is the second row, and platinum and gold. So if you don't know the electron configuration, so all of them finishes as S1. Palladium, except palladium. Palladium is very interesting. It finishes as 0. Okay, you have to consider it. And then I think that's all. Since these are also finishes again as S1. And this is also S1. So you have to memorize these elements. And that's all. After the memorization and after the inorganic exam, you can forget it. It's fine. But before the exam, you have to know that.